Okay, I've got a function here, g of x is equal to x minus x cubed. And I want to determine where this function is increasing or decreasing. So I'm going to take the first derivative. And finding the critical points, I'm going to set that equal to 0. And I'll have 3x squared then equal to 1. X squared is 1/3. X is equal to plus or minus 1 over the square root of 3. So I've got some critical points here. A negative 1 over the square root of 3 and a positive 1 over the square root of 3. And that kind of breaks up the domain of the function into intervals. And you know that if the derivative is positive, that means the slope of the tangent line is positive. And the slope of the tangent line being positive would mean that the function is increasing. So also the critical points here where the derivative is equal to 0, the derivative can't go from being a continuous function, can't go from positive to negative without going through 0. So the only place the derivative would be able to change signs is around these points where it's equal to 0. There are also candidates for where the original function could have an extreme value. The derivative being 0, a horizontal tangent line, may indicate that the original function has an extreme value. So I've broken the domain up here into 3 sections and also labeled some easy critical points that I can check what the derivative is doing. So remember, I'm plugging these into the derivative function. If I plug in negative 1 in the derivative function, I'm getting negative value. 1 minus 3 times negative 1 squared is 1 minus 3, or negative 2. So all of the values to the left of negative 1 over the square root of 3 are negative. That means that the original function g of x is decreasing in that interval. Decreasing in the interval from negative infinity to negative 1 over the square root of 3. Now looking at the middle section there, putting 0 in for x, the first derivative is 1, and that's positive, and that means for all the values in that interval, the derivative is positive, which says that the original function g of x is increasing. So g of x is increasing on the interval from negative 1 over the square root of 3 to positive 1 over the square root of 3. And then to the right of 1 over the square root of 3, I have that test point of 1, and putting 1 into the first derivative, I am getting a negative. So all the values there from 1 over the square root of 3 all the way out to positive infinity, the function is decreasing again. Now, to determine the whether there's extreme values, I know the derivative is 0 at negative 1 over the square root of 3 and 0 at 1 over the square root of 3. But because the sign changes, in other words, the original function is decreasing and then becomes increasing at negative 1 over the square root of 3, I know that I've got a relative minimum there. For a function to be decreasing and then start increasing again, I've hit a low point somewhere there. So I have a relative minimum at x equal to negative 1 over the square root of 3. Now at 1 over the square root of 3, my other critical point, the function is going from, or the derivative is positive, so the function's increasing to the left of that and then goes to decreasing. So something that's increasing and then starts decreasing has hit a high point. So I have a relative maximum x equal to 1 over the square root of 3. Now, those are where the relative minimum and maximum occur. The relative minimum, though, is g of 1 over the square root of 3. Actually, negative there. And that is roughly, I went ahead and give a decimal approximation. That's approximately a negative 0.39. So this function has a relative minimum at negative 1 over the square root of 3. And that relative minimum, that minimum functional value in that around that point is negative 0.39. It has a relative maximum at the x point 1 over the square root of 3, and the relative maximum is, well, I'm going to plug in that point into the original function and see how big it gets. It goes all the way up, and this is approximate because I wrote it as a decimal, 0.77. So I have a function here that has a relative minimum occurring at x equal to minus 1 over the square root of 3, and a relative maximum occurring at 1 over the square root of 3. Function is decreasing until it gets to negative 1 over the square root of 3, then it begins to increase until it gets to 1 over the square root of 3, and then it decreases again and produces two extreme values.